Hi, I'm Kevin. We're going to do an epsilon delta proof of the function 2x plus 5 as x approaches negative 3. What we can do is, since this is our main definition, we've got to do a bit of scratch work first. So the first amount of scratch work is find what delta is going to work. So what you do is you work backwards. You start at the end of what you're trying to prove, plug in all your values, and then go ahead and rewrite it so you're able to prove what you started with. So in this case, we know at this point that the limit as x approaches negative 3 is going to equal negative 1, and we can see it graphically. So in this case, we're starting at the end. So we know our function, in this case f of x, which is equal to 2x plus 1, and minus our limit is going to be less than epsilon. Okay, and what we're trying to figure out here is a delta that's going to work for this proof. So let's just at this point plug and chug. So here's our absolute value of 2x plus 5 minus our negative 1 minus our epsilon. Do a little bit of arithmetic, and what we get is 2x plus 6, and this is less than epsilon. Okay, now what we're trying to prove is that number that we're approaching a is negative 3, so again what we're trying to do here is manipulate this so that we get an x minus, or I should say an x plus a 3, considering it's negative 3 that we're moving towards. So what you can do here is factor out a 2. Alright, so I have an x plus 3, which is less than my epsilon. Go ahead and divide by 2. And what I have here is I have an x plus 3, which is less than my epsilon divided by 2. So this is the initial scratch work that we do. And what we're going to do is let epsilon over 2 equal our delta. So we found what delta we should use, and we're going to say let delta equal epsilon over 2. So that's the first thing we have now, and what we're going to do is plug in this epsilon over 2 for delta, and then we're going to use this and go ahead and prove what we have over here. So we're now going in reverse. Okay, so we have all this. Now we're just going to go and plug everything back in, and we can now officially do the proof. So here's our delta that we've chose, epsilon over 2. I'm going to erase, and now we can do the official proof of it. So what we want is we start with this statement over here, and we have x minus a, which is less than our delta. In this case, we know our delta is equal to epsilon over 2. And in this case, what I know that the a that I'm approaching is going to be the negative 3. So let's do a little bit of arithmetic, and we have x minus our negative 3 less than our epsilon over 2. I'm going to multiply both sides of the equation by 2.
The absolute value.
And
Is that the absolute value, the x?
yep, oh, sorry about that. So here's the absolute value there. And then what we're going to do is multiply this through, so I get 2x plus 3 less than epsilon. Multiply this 2 through, and I get 2x plus 6 less than epsilon. And this is what we wanted to prove. Now we know that 2x plus 5 is our original function, so when I break this out, we're going to be left with 2x plus 5, and in this case we have plus 1 less than epsilon. And if I make it look perfect, we've got 2x plus 5 minus our negative 1, which is our limit in this case, and this is what we wanted to prove, which is f of x minus our L is less than epsilon. And that's a full proof.